Hello everyone! In this video, I will show you how to use kNN search to retrieve documents after embedding them. This search method is applicable only if your index contains a dense vector field. In video number 16, we learned how to convert text into dense vectors using an embedding model. But how do we search within these embedded documents? The solution is kNN search, which is specifically designed for fields mapped as dense vectors. It's important to remember that you cannot use the query parameter for this type of search. Now I will give a brief overview of the kNN algorithm. This algorithm is widely used for both classification and regression tasks. To classify a new data point, kNN identifies the k closest points to determine its classification. Various distance metrics can be used to find the nearest neighbors, such as Euclidean, Manhattan, or Minkowski distances. If you want to read more about distance metrics, please check this Medium article. Overall, the kNN algorithm is simple and effective for many applications. If you are interested in diving deeper into the kNN algorithm, I highly recommend watching this video. You are going to enjoy it. Let's now walk through an example of how to implement kNN search. When using the search method, you need to specify the index. But after that, as I told you in the beginning, we don't use the query parameter, but we use the kNN parameter. Here are the key parameters for kNN search. We have field, query vector, number of candidates, and k. Now let me explain to you what these parameters do. Field. This must be mapped as a dense vector. For query vector, this represents what you are searching for, but in vector form, not text. Be sure to embed your query. So here you can see that we are using a method that will take the text and convert it into a vector of numbers. Number of candidates. ElasticSearch will retrieve up to 50 relevant documents in this example before applying the kNN algorithm. Basically, here if you have, for example, 1,000 documents in your index, instead of using the kNN algorithm on all those documents, that will take a lot of time. So by specifying 50 for this parameter, ElasticSearch will try to analyze the documents, and it will take 50 documents, and the kNN search or the kNN algorithm will be applied just to those 50 documents. Finally, we have the k parameter. This defines how many of the closest documents to the query should be returned. In this example, it is set to 10, which means that it will return the 10 closest documents to our query. Now let's go to VS Code to see how to implement this. Open notebook number 17. One more time, if you want to get these notebooks and the slides, go to the video description. There you will find a link that will take you to GitHub, and feel free to clone the repository to get these materials. If you want to read more about the kNN search, please click on this hyperlink. First, we need to connect to Elasticsearch. Here I am creating a new index with a field set to dense vector. This is important. To use kNN search, we need to have at least one field with the data type set to dense vector. We have talked about this. Here we are going to use this machine learning model or this deep learning model to embed the text. Make sure to install the sentence transformer library. Here I already downloaded the model, so this process will be very quick. But if you didn't do this before, you need to wait for the model to download. Here I check if I have a GPU, which I have. If you don't have a GPU, this will fall back to using a CPU. And the process will be fast even if you use a CPU because we have few documents. Here I created a new JSON file, so we will not be using those dummy JSON file that we were using before. This one, I have the theme. I chose to use astronomy. I like it, and here are the topics that we have. So we have a document that describes the solar system. We have black holes, galaxies, etc. So at least we have a good data set to work with. It's totally different and it's better than using the dummy data. Okay, so here we are retrieving the documents. And here we have seen this before. Basically, we are using the bulk API to make one API call and here the operation is index, which will take the documents and put them inside the index. And because we have text inside the content field, we will take that and convert it into a vector. To do that, we use the model that we downloaded from Hugging Face. It provides us with the encode method. As you can see, it takes in the text and it returns a vector. Let's do this. So as you saw, it was very fast. And as I told you, you don't need a GPU to be able to use the model. And here it says errors false, which means that all those operations were successful. Here, I have done this in the previous video. Here we are not using kNN search, but we are just trying to retrieve all documents to see if the embedding was done or not. And as you can see, we have the embeddings for all documents. Great, so now we can continue. Here we are again just verifying. So we are, let me remove this, or let me just make this bigger. You can see that the embedding field is a dense vector with 384 dimensions. Now we can start with kNN search. Here I have the first query. So here, this is what I want to search for. I want to search for a document that talks about black holes. So this is my query, and I need to convert it from text to a vector. This is why I am using the getEmbedding method. Now let me make this bigger because we will need it. You can see that we have one document that talks about black holes. So the kNN search should be able to retrieve this one instead of the other ones. Okay, so here you can see that I am using number of candidates, which is equal to 5. Here I think I have 10 documents. Yes, I have 10 documents, but ElasticSearch will try to analyze them and retrieve 5 documents. We will take those 5 documents and apply the kNN algorithm to them to get the 3 closest documents to our query. So by just doing this, we can print how many documents we got back. Let's verify that this is working. Okay, great, it's working. Let's keep it as 3. Here you can see that I am looping through all documents, and here I am printing the title and the content as well as the score, because when using kNN search, the closest document will have higher scores. As you can see, the closest document is black holes. The score is 0.88, while the other ones are very low because they are close, but this is not what we are searching for. This is what we asked for. What is a black hole? And this document should have the answer. That's why it was the closest one. Great, so that actually works. Now for query number 2. How do we find exoplanets? Let's search for this term. You can see that we have a document that explains what are exoplanets and how do we find them. We use the transit method and radial velocity to find exoplanets. So we should expect to get this document first and some other documents in the second and third position. Let's do that. Okay, again, I need to replace that print statement because it's not giving us the number of documents. Sorry about that. Yeah, now it says found 3 documents. Good. Let's print them. And once again, you can see that exoplanets is the closest document. For example, if you want to get just the closest document, you can replace this by 1, and here it will get you the documents. For example, exoplanets. But sometimes you will have a lot of documents that are related to your question. In that case, increase k to 3 or even 5. That will be enough. It depends on the size of documents that you have. Generally, you can play with this value. You can see that here in the end I said that we observed that the documents with the highest score consistently corresponds to the query. But as I said, this depends. If you have the answer in one document, then the document with the highest score is the one that you should take. But if you have the answer in multiple documents, then this does not matter. You can take 1, 2, or even 3 documents and then extract the response from them. We arrived at the end of this video. I hope that it was helpful and informative. Please, before leaving this video, leave a like and subscribe to the channel. And if you have any question, please write it in the comment section. I will help you to find the answer. Have a nice day. See you next time.